everyone, and welcome back to another Grafana Office Hours. I'm Nicole van der Hoeven, developer advocate at Grafana Labs, and over here with me is not Paul, but someone a little a little fairer. And I think this might be your second time at Grafana Office Hours.
It's my first time
Oh,
actually.
first
Well,
time.
yeah,
Okay.
because the last the last one was with the 100th episode of K6 Office Hours, but officially on the Grafana Office Hours. Yeah, first time here, so really great. So my name's Marie. I'm also one of the developer advocates here at Grafana Labs.
And down there is someone whose first time it also is on Grafana Office Hours or on K6 Office Hours. Imagine that. Łukasz Gut, welcome to the stream. It's great to have you with us.
Thank you so much. Thanks for having me.
Okay, tell us what you do, why you're here, where you're based.
Cool. So I'm Łukasz. I'm based in Warsaw, Poland, and I'm a senior software engineer here at Grafana Labs. Currently, I'm leading the K6 Insights team that's responsible for the integration that we're gonna talk about today.
Awesome. How long have you been at Grafana Lab or at K6?
So I joined Grafana around 1 year ago, August last year, and I've been working here for K6 backend ever since. And yeah, I joined as a sole contributor, and now there is two of us in a team.
There's a fun fact as well. So Lucas and I joined I think you joined a week before I did. So
Oh,
it's
really?
yeah, so we've been in Grafana for 1 year and we're sporting our 1 year Grafana anniversary mug. But yeah, I remembered when we were doing all the onboarding sessions. Yeah, Lucas and I were both there representing K6.
Yeah.
So when you joined us, Łukasz, were you told what you were going to be working on, or did that happen afterwards?
Yeah, so more or less, I was aware on what I was going to work on. This was also one of the reasons I actually joined. So I got to experience Grafana and K6 for the first time at my previous role. So before joining Grafana, I was actually working at TikTok, also as a backend engineer, primarily dealing with network infrastructure and optimizing it. So this is the first time when I was working back there at TikTok when I actually used Grafana software. We used the open source version to do some internal monitoring, and I also got to play around with K6 a little bit since before actually releasing our product to production, we had to do some load tests. So Grafana K6 was one of the tools that we evaluated back then, and we used it uh, to do performance testing essentially. And when I was looking for a new job and I saw that the Grafana has an opening, and when I actually joined the interview with Pavel, who is the CTO of K6, it actually struck me that I'm interviewing for the K6 team. I wasn't aware at that time that K6 was acquired by Grafana. So
Oh,
yeah,
that's so
when I saw
cool.
this, it was lovely because I knew both Grafana and K6 as products, and we had a great conversation back then. And yeah, we talked a little bit about the potential future of the features I might work on, and distributed tracing in Grafana Cloud K6 was one of these topics.
So did you already know a lot about tracing, or was it something that you learned along the way?
Yeah, I was very familiar with tracing since well, at TikTok, all of the systems were instrumented. It's a huge company, so they've been running distributed tracing
Mm.
definitely since I joined. So I was aware of what distributed tracing is. I also knew how to use it, and yeah, I was basically familiar with the concepts.
Before we actually get into this, because I would love to get some sort of introduction on tracing, Marie, do you have an announcement for us?
Yeah. So it's just really to share to everyone that the Grafana Observability Con is happening next month. I believe it's gonna be held in London, and I think it's on the 20. Sorry, not 20. Like 16th to 17th, if I'm not mistaken. But essentially, there's gonna be a lot of talks, amazing speakers as well from Grafana, and people from the community who also use Grafana. So if you're in London, if you're interested in hearing talks about Grafana and what the different use cases are, then I think this is a really great conference to be part of.
Great. My announcement is that later this month, I'm going to be in Lithuania, in Vilnius, Lithuania, speaking at TestCon Europe. And I'm going to be talking about something kind of related to what we're talking about today, actually. It will be about K6, but in a slightly different context. I'm going to be talking about emergent load testing, what that means, and how to make smarter load tests that maybe are a little bit more generative in nature. So this is the link to that. If you want to go, there's still time to catch my session. But now let's go back to you, Łukasz. Tell us, what is distributed tracing? What are traces, and why do we even need them?
Yeah, great question, Nicole. So I actually prepared a little definition. So maybe before we jump into that, but okay, it's okay actually that we have this on the screen. So I wanted to read us the W3C definition first of what distributed tracing is. Then maybe I will provide a definition of my own that I also find useful and try to explain what's what essentially. So W3C defines distributed tracing basically as a set of events that are triggered as a result of a single logical operation and are consolidated across various components of an application. So a distributed trace contains events that cross process, network, or security boundaries. So as you can see, the definition is quite lengthy, and it's not entirely obvious what a trace is after you read it.
Yeah.
So I have slightly
different.
different.
I feel like I know what a trace is, but when you read that, I'm like, do I?
Yeah. I felt confused even more.
Yeah. Sorry, go on,
Yeah.
Łukasz.
Yeah. So the definition is kind of generic. So my take on tracing, of how I like to think about it, is that for me a trace is simply a way to follow some unit of work across what I call context boundaries. So in the previous definition, a few of these context boundaries were listed. So a context boundary can be a process, can be a network, can be a function call, right? So a distributed trace doesn't, even though it has distributed in its name, it doesn't necessarily have to be between different services. So tracing can also happen within a single application. So this is where this kind of context boundaries comes from, right? So a trace is basically a set of operations that are linked together, but what we call a trace ID. And in the end, they just form a simple graph. So maybe now we can actually share my screen so I can talk a little bit about this on the example that we have. So this is a pretty generic example. On the left side, we just have a graph. We can imagine that this graph represents a set of microservices that are interconnected with each other. And service A to serve a request has a dependency on service B and service E, right? And then service B has a dependency on service C and service D. They can run in, so this could be either services, this could be simple functions. It doesn't really matter. So when we follow this unit of work, as I mentioned before, it can either happen locally within a single service or a single process, or it can be a separate microservice, right? And then we have to cross, for example, a network boundary. So when we take a look at this, a trace is, a trace, as I said before, is basically started with a single logical operation. So in this case, we can see that an arrow is approaching the A circle. So this is usually what triggers a trace. We have some request that maybe reaches your microservice, and it has a unique ID. Before I told the trace ID, right? So this trace ID is globally unique, and this is how we basically link all the traces or all these spans together into a single trace. So each of these steps can be or is in tracing nomenclature called a span. So I said before that trace is just a set of spans. So what is a span? So a span is the single unit of work or operation that also has its own ID. So if we want to identify a span, we have to use the combination of the trace ID and the span ID. And so this is how we could, if we mapped a set of distributed services or microservices into a graph, the left side is what we might look at. However, the right side here is what you would actually see in some tracing front end, such as Grafana, when you actually want to visualize the trace. Obviously, there is also some front ends, Grafana does it, support what they call service maps. So you can basically infer the relationship between services based just off of tracing. But the right side is what you usually look at when you try to analyze a trace. So here we can see that basically there was some operation A that started operation B and E, and operation B started operation C and D. And we can basically see this in this sort of tree view, where we have an operation A that starts at a particular point in time. Then A starts B, and we can see it that one caused the other because it's nested. Then B starts C. After C finishes, D starts. This is also something that traces allow you to visualize. So basically, you can also see whether some operations happen concurrently or sequentially. In this case, we know that that D happened after C. So these are sequential requests. But it is possible that D would be just under C if these operations were happening concurrently. And then after B finishes, we can see that operation E happens sequentially. And that's all. So this is basically tracing 101. It's just a way of tracking this unit of work and following it through some context boundaries, either through function calls within a process or through a set of microservices.
Yeah. It sounds like tracing really is sort of like a representation of the complete journey of, let's say, if a user sends a request or there's a transaction, and then you want to trace like what the journey is from one component to another, so that represents the entire journey. And then on the other hand, the spans are like the individual steps, so it could be checking if the um, request has hit an api, and then if that API has hit a database query. So it's all like the modular blocks, and then in collection that makes up a trace. That's my understanding of it.
So I like to
Yeah,
kind of take it a little bit more to real life, and I always like to use the analogy of a car. And I like to think of a request as a car that you're sending out there, but you might already be tracking a lot of information about the car. You might be tracking like how much gas it has or whatever, and that stuff those are metrics. But the trace is tracking something different. It's showing where it's going, where that car went. So in that graph, that I think this is called the directed, what is it called, directed acyclic graph, on the left, what this is showing is like these checkpoints of where the car is getting to. It might go through all of these points, it might go through some of them, but the span is like that leg of the journey from A to B or B to C or whatever it is. And sometimes it's like the entire thing from the entire path that it took. So I kind of like to think of instrumenting in this scenario as putting a tag on the car, like one of those e-passes, where so they know how much to charge you. It's like you pass through this thing, it goes beep, and it's like, oh, you went to this particular toll booth, and that way I know where that car went. I kind of like to think of it that way. But I guess let's talk about why you even need to know that. You send a request through, and if you already know the architecture, then why do you have to know exactly where that request went? You know the path it's going to take.
Yeah. So let me get back to this question in just a moment. I just wanted to supplement a little bit what we were just talking about. So you made great analogies and described a very valid use case, which is tracking a single request, how it flows through a set of microservices. However, tracing or distributed tracing is a very generic concept. It doesn't really have anything to do with HTTP requests per se, for example. It can have something to do with it, and it's a very valid use case, but tracing is a generic concept and can be applied in many different ways, right? This is just one of the use cases. So I just wanted to throw it out there.
That's a good point. Yeah, I guess I always jump to that use case because I'm a load tester.
Yeah.
Yeah.
Is it because it's
probably
one
the
of-
most common.
Yeah, I was gonna say the
Yeah.
most common use case.
Yeah, so it's definitely common. All right, so why do we care about tracing? So let me pull up another image I actually found like 5 minutes ago before we started on the internet. I think this one is from the Microsoft documentation.
What do you mean? We were totally prepared, Łukasz.
This is being prepared, right? You just have to know where to look for images like this. Anyhow, so why do we care? So tracing is currently considered to be one of the 3 pillars of observability, the other 2 being logs and metrics. So traces, the same way other pillars of observability or other signals are not required, right? But they are very, very useful. And you only know the value of them once you actually start using them. So before I answer your original question on why should we care, maybe I will go over the other 2 signals, because I think it's worth differentiating between all these signals and what they actually can tell us. So let's start with the most obvious one, which is logs. So logging is essentially what every engineer or every developer does the first time they start programming. When you start programming, you usually start with printing hello world, and this is the first log you ever produce as an engineer. So logs can take this form of just a plain text message without any additions. But usually when we talk about logging in production or in real systems, logs usually refer to time-stamped records that usually also contain some context, and I will explain what context is in a minute, and a message. So what is a context? So a context attached to a log can, for example, be just a set of key value pairs that represent maybe the instance IP address that emitted this log, or maybe they have a key of service name and then the actual name of the service that produced this log, right? And then obviously they also contain timestamp and the messages, whatever message you want to emit. So logs are extremely detailed. They are not connected with logs being emitted from other services. There are tools to kind of try to do this analysis, but by default, logs are not interconnected between each other. They are just distinct events or records that happen that we emit, and they usually contain very specific information. Now let's move to metrics. So metrics on the other side, I assume probably a lot of people are already familiar with metrics. When we think about metrics, we just picture this beautiful time series on Grafana dashboards. So metrics are numeric representations of data measured over intervals of time. And this data is usually, when it comes to metrics, aggregated. So you don't get this fine-grained view over your data, because they are usually aggregated into some time buckets. For example, you usually aggregate metrics every 30 seconds. And then when you look at a metric like, let's say, a request rate, so a metric representing how many requests, for example, per second reach your microservice, you would see only the aggregation in this 30-second bucket. So you wouldn't be able to see the individual requests, but you can more or less average out or get the percentile, for example, for the request rate. Sorry, percentile maybe for latency, maybe not for request rate. But in general, it's aggregated. So this is important. And then traces are maybe not something in between. This is this is pretty interesting, because traces are a third pillar of observability. They are definitely the newest one, especially when it comes to open source communities, and now the democratization of tracing is happening as we speak. When we look back in time, it was usually metrics and logs, and tracing was very expensive and only done by big tech companies. Now it's getting democratized. So we already talked about it. What tracing does is very similar, maybe not very similar to logs, but it allows you to link between some different operations, right? With logging, you could only see what happened at a certain point in time, usually very, very detailed. When it comes to traces are slightly less detailed. You usually don't have a new span created for each operation you do in your microservice, because such traces would be very hard to look at. But maybe you create a span when a request hits your service, and then maybe you create another span when a request goes out of your service, right? So if something goes wrong, you can actually record some sort of an error, for example, to a trace. So traces then would allow you to very quickly identify where the problem is in the whole flow chain, which is very different from metrics and logs. In theory, you could do this with logging, but it's extremely cumbersome.
I mean, I think in theory, logs could do everything. I just posted a video to another Grafana Office Hours I did on Loki with our colleague Ward Becker. And he was saying he had a complete dashboard built out where it was just all logs, and he just transformed everything to look like they were metrics and other things. But just because you can doesn't mean that it's always the easiest way to do it. But the reason that I am really personally interested in tracing is because I think that there's a very clear shift in the evolution. Actually, in the last office hours, just last week, we were talking about the history, the evolution of distributed computing in general, and how the shift into smaller and smaller containers, and then now it's like Kubernetes pods, and it's still becoming more and more modularized. And there are advantages to that, but there are also disadvantages. And one of them is complexity. Maybe it didn't matter so much when you only had a handful of services, and you didn't really need to know. Maybe there weren't so many different paths where a request could have gone, but now there are a lot of places that it can go. So even if you know the entire architecture, finding out where it went is still very important. Otherwise, you just get like, there's an error, but where?
Yeah.
Don't know. Like, how are you going to figure that out? It's just like this big black box. And without tracing, it is hard to pinpoint which specific component you need to look at.
Yeah, that's true. Also, I will comment a little bit on the evolution over years. So it is true that distributed tracing is It's something new, something fresh. However, some form of tracing has been with us for a really, really long time at this point. And what I usually compare distributed tracing to is just profiling, CPU profiling to be specific. So CPU profiling has been known to humankind, or at least engineering kind, for quite some time now. And it's people heavily rely on, especially in some high performance scenarios where you really have to go and dig deeper into your application's performance. But when you actually look at profiling, you would see basically the same picture. You would see a function call, right? And then just below it, excuse me, another function call, right? And and so on and so on.
We also have a comment here from Falcon Codes, by the way. They say, great topic, guys. Tracing helps in monitoring the performance of applications. It can pinpoint bottlenecks, latency issues, and areas where improvements are needed. And then they continue, by visualizing the duration of each operation within a request, you can identify which parts of your application are slowing down the overall user experience. And to your point, Łukasz, we have for a very long time in the performance testing world also had something that looks very similar to the spans as well. In the network panel, you can, it's not the same, but it is the same sort of approach of trying to figure out, from this whole, from this singular latency or response time, what part of that did that request spend at which component?
Yeah.
Exactly. So the same way as profiling. The idea is not new. The application of the idea is rather new.
Yeah. It's really good that you brought that, Nicole, that in terms of the architecture now, it's much more distributed, because if there is an issue in production and you're trying to pinpoint like where the performance error is coming from, and imagine if you only have, I guess, a handful, a bunch of logs that you'd have to look into like individually, and that can already waste a lot of time, and that can lengthen your mean time to recover, and then in turn you're losing users because they're, I don't know, going to a different website. So it has a monetary impact to the business as well, whereas if you have some sort of distributed tracing in place, then you could easily pinpoint, it might be because one of my database query here hasn't been optimized, or it's not been indexed properly, so at least you'll be able to have that information quickly.
Yeah, while we are talking about logging and tracing and the relationship between the two, I would like to highlight that not all, but some implementations of distributed tracing, OpenTelemetry for sure has this option. You can actually attach logs to traces. So then when you take a look at a trace and navigate to a span that's, for example, taking a long time to finish, or has recorded an error and is basically read in your user interface, you can click on it and you could see associated logs. So you don't have to dig through all the logs from your system. You actually can already get a curated view of all the logs that happened within this trace context. It's also very useful for debugging.
Yeah. So I think that where this is fairly new, where distributed tracing is fairly new, is in its application to testing in particular, because it hasn't been very long at all that I started to hear any sort of tracing being attached to testing activities in general. I think that's because of this whole black box mentality, where it's also very siloed, like testers are here and devs are there, and then ops engineers are somewhere else, and we don't really communicate in the silo situation. And so testers were always initially expected to just focus on in this case, the load test or whatever they're running, and not really, we weren't really expected to follow each request through to the path that they took within the application. I think K6 is one of the first ones that can support this kind of behavior. I know, certainly from an open source perspective, I know that Dynatrace also started with this fairly early on, where they were instrumenting headers, but it is also a whole, it's a very large platform and not open source. So can you tell us, maybe before we get into what else is out there, maybe you can tell us how this works to begin with. Like how do we use distributed tracing with K6 and with testing?
Right. So there is a couple of things to it. So first of all, we have implemented a new tracing module to K6 open source. So everybody who is using K6 open source, they can just import the currently experimental tracing module, but we will be graduating this as we go. And basically, they can either instrument all of their requests, all of the HTTP requests. This is pretty important. There is no gRPC support for this just yet. If anybody is willing to contribute and provide gRPC support, we are more than willing to accept your solutions. But it's coming. However, yeah. First things first, there is the new tracing module in K6 that you can import, and you can either instrument all of your outgoing HTTP requests with tracing, and you can add the tracing headers, basically, using what we call a propagator. So we build this propagator, which is just a tiny abstraction on top of different tracing implementations that you can basically use to specify the tracing format we are using. Since there is a lot of conflicting standards, I talked about OpenTelemetry before, but there is more implementations of distributed tracing than just the OpenTelemetry's one. There is an implementation very popular from Jaeger. There is also the Zipkin implementation, and I'm sure there is probably at least tens of others. So this propagator that we have, you can basically use it to set to propagate traces in the format that your backend understands, right? Because if you instrumented your backend maybe 2 years ago or 3 years ago when there was no OpenTelemetry implementation of tracing, I'm not sure when did they introduce it. For full clarity, but let's say it was 3 years ago, right? So if you used Jaeger before, you can basically specify Jaeger as a propagator, and K6 would send traces in the format that's understandable by Jaeger SDKs that you use to instrument your actual services, right? But you could also choose W3C, which is the standard for OpenTelemetry. Yeah, so this was the first part of it, right? We have the new tracing module. And then we have the distributed tracing in Grafana Cloud K6, which is a brand new feature that we're gonna showcase probably just in a minute. But before we do, I can walk you through how it more or less works. So yeah, here is the K6 rectangle that we have here, right? And I just mentioned that you can import this module and start sending instrumented HTTP requests. So here is this arrow that showcases that K6 targets some customer services, right? So these are the systems under test that you have, and that K6 is basically sending requests to. Then a very important part of tracing is to actually collect those traces. A common pattern in software engineering currently is to have some form of agent deployed next to your applications, either as a sidecar or like a shared container, maybe in a Kubernetes node. Basically, some form of deploying an agent that can collect these traces that are exported through what we call exporters in OpenTelemetry conventions to this agent, and then the agent will further export those traces to some form of long-term storage backend. One such long-term storage backend that, for example, Grafana offers is Grafana Tempo, right, which is our open source database for tracing. And obviously, we also have the cloud offering that we call Grafana Cloud Traces. So when K6 sends all those traces to your services, right, a lot of stuff is happening if you have a lot of microservices, but eventually the agent collects them, sends them to Grafana Cloud, specifically to Grafana Cloud Traces. And then on the other side, we combine it in our backend with some metadata that K6 exports. And then we allow you to visualize all of this in Grafana Cloud K6, which is our front end for K6 testing, essentially. All right, should we move to the demo? Or
yeah, we have a question from Holger Winkelmann. He says, you might even trace your whole test run?
You might even trace your whole test run.
I think he's asking if you can trace your whole test run. And the answer is yes, if you instrument there are a few things, I guess, that we should say you need first. The application has to be instrumented separately. Łukasz was already talking about different ways, different formats that you could have chosen. But you also have to do something on the K6 side, on the script side, where you are instrumenting, where you're specifying what format you're using, and then also instrumenting every header. But once you do that, then yes, you could trace the HTTP requests in your test run.
Yeah, that's for sure. I see also a reference to a trace test in another comment, but maybe we can actually come back to this topic after the demo, because trace test is another implementation that is slightly different, or approaches kind of the same concepts in a slightly different manner in the context of software testing. So maybe I can show what we presented, and then talk a little bit about how this differs from Tracetest, which is also an amazing open source project. All right, so the demo part. So what we are gonna be actually testing today is this little hot rod application. So this is an open source application. It's actually a demo application of the Yega project. You can go and see the code for yourself. If you Google it, you can find it on GitHub. And the application is very simple. It has the front page, obviously, and then it has the buttons. So we have 4 buttons here that represent 4 different customers. And the idea is that when you click on a certain button, you kind of order a taxi or a cab to your place, right? So if I click here, the cab is being ordered for Rachel's floral designs. Probably it's like some kind of a shop or whatever, right? Maybe, we click another button and we order basically a taxi at another location. And this is it. So it only has 2 APIs. One where we basically dispatch cabs by clicking a button or making an HTTP request, as we're going to see in a minute. And then we also have the homepage. So this is our system under test that we're going to be testing today. And I have actually prepared a little K6 script to show you how this distributed tracing in K6 works and what it can help us find within our system. So let's go one by one. This is a very regular K6 test. So at the top, we have just a bunch of imports. We import some sleep functions, so we can sleep between requests and kind of simulate more real-world site usage. We have a function to do some randomization. We import the HTTP module for actually making HTTP requests. And what's most important, we import the tracing module.
So I have a question about that, actually. Because the last time that I looked at this, we weren't using the K6 tracing experimental module. We were still using XK6 distributed tracing, which is the extension. And I believe at that point, I think the difference that as I understood it, was that XK6 distributed tracing could work with what we were calling, Croco spans or insights, or I'm not sure what you call it now, this distributed tracing thing that you've been working on. But K6 tracing, the experimental module, did not work with that yet. So is that like, are they just the same thing now, or what's the deal?
Yeah, so the XK6 distributed tracing module was the original module that we created to start integrating into the K6 ecosystem, but not be in the core just yet, as we were experimenting with different approaches. And now it has made it to the experimental stage. So we could consider this. We could consider that it graduated, so to speak, into being experimental, and we hope, and I hope to see it personally, graduated to a core module down the line. So XK6 distributed tracing, the extension still works. It can be used, and it can actually add tracing to your requests, but it won't work with the feature that I'm gonna present.
Yeah.
Okay,
So is
this
it?
is.
Oh, sorry,
Go on,
Nicole.
Marie.
Is it safe to assume then that going forward, we want users, if they want to use the distributed tracing in K6, that they would use the experimental module rather than the XK6 distributed tracing extension?
Yeah, definitely.
Yes, that's good to know.
Yeah, it's also
Alright.
good because that means no custom binary is needed. You don't have to compile that separately. You just have to do the import line, which is great.
Yeah, exactly. Cool. So let's continue. So we stopped at importing the tracing module. Then we import Papa, which is just a CSV parser, because we actually have a little CSV file that represents customers. However, as you can see, we have 5 customers here, not 4, because the 1337 customer is actually an invalid one. We just throw it out here to see how the system performs and how the system reacts to invalid input. So we're gonna see that. Okay, what's next? As I mentioned, we are targeting this particular URL. This is our application deployment. Here in the next line, I just import and parse this little CSV file into a map. And then this line is what actually adds instrumentation. So you can see that I call the instrument HTTP function on the tracing module, and I'm specifying a propagator. So a propagator here, as I explained earlier on, is just a way for us to define the format of traces that will be sent to the system under test. Since we use hot rod application, and that's been part of the Yega project, and it's been instrumented with Yega, not W3C. We actually put Yega here. But if you use OpenTelemetry for instrumenting your applications, you could actually just use W3C as the propagator, and it will just work magically for you.
Can I ask a question, Łukasz?
Yes.
So what if you accidentally provided the incorrect propagator? Will the experimental module throw any error, or you just won't see any traces at all?
Yeah, so for now you won't see any traces at all. So basically, giving some more useful tips on why this is not working for you is something that we are looking to improve on. So for now, you won't notice. So you have to know what SDKs you used for instrumenting your backend services, actually.
Okay. Did I write the script?
Yeah, it's your script.
Okay. I was like, this looks very familiar.
Yeah, it's your script. It's great. Cool. So we have a couple of scenarios. So First of all, we have home and the dispatch scenarios. So these scenarios will happen concurrently when we run the test. And in the home scenario, will basically just try to access the homepage for 1.5 minutes. And it's just gonna be a very regular, not too crazy load test with 10 virtual users, right? And at the same time, you're gonna be dispatching cars. So you can see that the home scenario executes the homepage function, and then the dispatch scenario executes the dispatch function. So we're gonna take a look at these two functions now. So what they do, again, very, very simple. The homepage function simply does a GET request to our URL, to our application, and tries to fetch the homepage. And then it does a very simple check to assert whether the status returned was 200, right? And whether body includes what we expect it to do, right? So this, basically, this title. And then the dispatch function, what it does is it just takes a random number to pick a random customer from the CSV file that we actually loaded in the first place. And then again, it does a GET request to our domain. However, it targets the dispatch endpoint and gives the customer ID. And then in both scenarios, we just sleep between 3 and 5 seconds. That's it. So coming back to our scenarios, these two will be happening concurrently. And then after these two finish, we will actually run a stress dispatch scenario that's going to ramp up the number of virtual users over time to 50, as we will see. And this is it. So yeah, basically, this is the only line that you need to enable distributed tracing in Grafana Cloud K6. And now, how do we run it? So there is 2 ways you can run it. You can either run just K6 Cloud, and it will just work for you, because for cloud executions, this thing is always enabled. But you can also run it locally, and this is what we are actually about to do. So to run this locally, you actually need currently to specify this little feature flag. So K6 Cloud Traces enabled has to be set to true. And then when we do run, we just have to output this data to our cloud, and we just run a test. So this is all it takes to run this test run. So I talked a lot. Let me just run this little bash script that I have here. Let's try to run it. And I think my talk is obviously.
Of course it is. Yeah.
Of course it
Demo
is. Okay. Can we take screen off for just a second so I can take a look at my
Sure.
talk?
In the meantime, actually, there's a question from Michał Niedojadło. I don't know. Am I saying that right? Łukasz?
Michał Niedojadło.
Michał Niedojadło. Did I say that right?
Yeah. Close enough.
Okay. Hey, in my apps, I just use an instrumented HTTP client that creates spans using OTel for every outgoing traffic, then Tempo visualizes them for me. What improvement would I get from switching to K6? So I have thoughts, but maybe Łukasz, you want to answer first.
Yeah, so actually we will just see this in the demo. I just need to pass the proper token.
Maybe you can share your thoughts, Nicole.
Yeah, one of the things that I was thinking of is that the majority in something like this, because he was talking about going from an HTTP client, he didn't say testing tool, to K6. So I want to highlight that these are two very different things. Usually when people say HTTP client, that could just mean one of these like record and replay traffic things. Or maybe it's just like a single request and it just hammers the server with that. I would say that that is different from being a proper testing tool. So I think most of the difference, the improvement that you would get is from switching from something that's a replay and recorder kind of thing to a full testing tool that can do scenarios like Łukasz did, and can be a little bit smarter about the kinds of tests that it's running. So K6 doesn't just do HTTP requests, for instance. It can also do, browser tests and a whole lot of other things, in even fault injection. So I think it's a little bit like, I think that's a comparison between two things that are very different outside of the tracing element of it. In terms of the tracing, it might also work for you. Obviously, that's already working for you, and you've gotten tempo visualizing it. I think it's the K6 and the kind of best practices around testing in general. That's where you're going to see the biggest improvements. What do you both think?
Yeah, I think you've hit you've hit it correctly, because like you said a while ago, when we talk about performance testing or load testing, it's always been a black box approach. And when we add the tracing aspect to it, it would just make it easier for us to pinpoint or to debug which parts of the application is hitting, some bottleneck issues. So it would, just make sure that in terms of the mean time to recover, I've mentioned this already, it would just be much quicker. So I think you'll get that advantage with the distributed tracing with K6.
Yeah.
Yeah.
By the way, I got my credentials, so we can actually switch and show me how what he's missing if he's not using Grafana Cloud K6.
Look at these
So,
pretty
yeah,
graphs.
Yeah, now the test is running. As you can see, it's been running for 1.5 minutes now, and the stress dispatch scenario is ongoing. So let's take a look at our little app. So this is what you end up with when you run a test and then stream results to the cloud, or run the test just in the cloud. This is your test run page, basically. And what we can see here is client-side data. And so these are some of the metrics that K6 produces, right? And we can, for example, go and take a look at the number of virtual users that are currently executing, the request rate with which we send requests to the system under test, right? The response time, and so on and so forth. On top of that, we obviously have everything grouped by, for example, the scenarios that we used, right? So I mentioned that we have a couple of scenarios. So we can, for example, go into the dispatch scenario and take a look at requests we were making, right? And surprise, surprise, or maybe not, we actually see that one of the requests is failing. And this is exactly the one that we expected to fail, since it uses the customer ID number 1337, right? So this is
everyone knows that's just lead.
Exactly. So this is all nice and dandy, and it's been in Grafana Cloud K6 forever. However, what's new is actually this tracing integration. So you will notice that we have this traces tab here, and we can either click on the traces tab itself and it will start showing us traces, or we can actually go and start exploring results other way. And I will actually show you this way. So let's take a look at our stress dispatch scenario, right? Because what we can notice here on our graph is that once we started ramping up the number of virtual users, the response time, the P95 response time, actually started increasing quite a lot, right? It was pretty steady at around 1 second response time. And then once we started ramping up the number of virtual users, we see response times of roughly 8 seconds, right? And it's still growing. So why is that? Until now, you wouldn't know if you just use K6, because what we can show you is that, yeah, indeed, the response time has increased, but there is no way to actually dig and discover why it has increased. However, now we have this beautiful view traces button that will show every time you run your test with the distributed tracing extension or module. So we can just click on it, and voila, here we just have a set of aggregated spans that were happening while we are running our load test. So let's actually go and take a look and see which one is taking the longest. And we can see that this is the HTTP GET/dispatch span that originates from the front-end service, and it's kind of is basically a server, right? We can see, for example, how many of these spans happened over the course of our test run in the context of a particular scenario group, right? So all the K6 concepts also apply to these traces. However, this is not the only thing that we can do. We can actually go and take a look at metrics. So we actually generate metrics from spans that are happening while the test is running. And we can see that indeed the duration is increasing. So you can take a look at the duration. Oops, I think our front end might have crashed. Let's just refresh it, and it should be good to go. All right. Yeah, so we can see that the duration is increasing, but we can also take a look at the span count and also the different percentiles. But what's even more interesting is that we see those little, are those rectangles? No, these are rhombuses, right? So we can see these little dots on our graphs, and these are actually exemplars. So these allow us to jump directly from metrics to traces. So we can just take a look at a particular exemplar that we are sure that basically took a lot of time to execute, and we can query tempo, and this way we can immediately see that what's taking so long to finish is actually this MySQL span, right? It's taking over 11 seconds to actually finish. The rest of operations in this trace actually seem to be finishing in a reasonable amount of time. So we can take a look at that, and maybe we can start analyzing this, right? So here we see that we actually hit an endpoint, a dispatch endpoint with customer 123, right? We can then see that, okay, we actually performed a select from our database with the same customer ID. So this is all nice and it works. However, it's slow, right? So let's actually take a look at the events. And here we go, right? We can see that the query was so slow because in this particular case, the query was waiting for a log behind 37 transactions. So it might mean that maybe our database is overloaded. Maybe there is too many concurrent requests happening, right? Maybe we need to put some sort of index on our database. There can be many different solutions to this problem. But we basically just jumped from a K6 test through a metric of how the spans performed over time to a particular trace that basically gave us the actual root cause of the problem we were looking for. And it's not only that, right? We can just go and take a look at this particular table and start figuring out what sort of services make up our entire system, right? Before, it was just a black box to us. We were just seeing what's happening at the client side. However, now we can actually start to reason about the system under test, right? We can see that there is some front-end service, there is some customer service, right? There is the MySQL database, there is driver service, there is some route service, right? Also Redis is used. So we get all of this information about our system that we are testing without actually going into code and trying to grasp all of the different things that are happening there. On top of that, obviously we can filter. So we can go and take a look at, for example, the home scenario, right? And the same thing here, we can just take a look at our HTTP GET root trace. And there is not too many spans to actually see here because this GET request is rather simple, right? But if we go to a dispatch scenario, again, we can start seeing different spans. We can also filter by URL. So maybe we want to take a look at the URL that was actually failing, right? And see here we can see that, yeah, there are some errors recorded in those spans. So maybe we take a look at one of these exemplars and try to figure out what's going wrong. So we can see that it failed here. So let's take a look. And we can see that, yeah, it was just an invalid customer ID, right? Mm-hmm. Exactly what we expected. So basically, we have this integration, and you can start to reason about your system under test. You can start digging deeper. So not only do we now show client-side metrics, right, but you have a direct way of linking and going from the client-side metrics when you see that there is some anomaly happening during the test run, all the way through the trace that is actually of interest to you.
Yeah. This is such a massive time saver because especially now where the lines between, QA and dev is really becoming blurry. So both Nicole and I, we come from a QA or testing background, and the way that you've shown it, like I don't need to ask other members of my team like, hey, can you help me understand the entire system? Because everything here, like I can just look at a particular trace and then look at the individual spans, and then it will give me the error messages where I guess the issue is happening from. So this is such a massive improvement just from the whole quality aspect of things, and it just makes sure that both QA and dev are really collaborating and not working in silos anymore. So this is amazing.
Yeah, I definitely agree. This is why I was actually so hyped to join Grafana and K6 in the first place.
Yeah.
This really has a potential of redefining the way we do root cause analysis for testing, essentially, right?
I also really like the specific example that you showed, because in that case it was a question of the customer ID being wrong. And previously, what would have happened without tracing being combined with testing is that we would have had an aggregated metric of that entire dispatch request, and we would have seen like X% of the time, I think there were 5, so maybe 20% of the time this was failing. And then we would have thought, well, why? And then we would have tried 1 to 4, and we would have been like, well, they work, so why did that fail? And this way, because of those exemplars, you can be like, no, it's just these ones. It's not all of these things, because when you have to aggregate at some point with metrics, right? But especially when you get errors, sometimes it's really not useful to have it aggregated up to that entire request when it wasn't the request that was wrong. The information that was being passed in was wrong. So that being able to spot that is really invaluable. I mean, you only had 5. What if we had like 100 and only one of them was wrong? And then we would have thought like, oh no, our server or that service, that component is going down or failing X% of the time. It's like, well, no, actually, we were giving it the wrong data.
It's not only that, it's also the fact that while the full request can actually succeed, parts of it, so certain spans can fail. And before, you would be like, okay, it's green, my system is working well, right? But now you can actually be like, okay, my system is working because I can see responses in a reasonable time. They are of correct status code. They return correct data, but maybe something sits inside the system that you want to analyze further, right? Maybe there is some opportunities for optimizations. Maybe you are, I don't know. We can actually go and I can show another example of exactly this what I'm talking about in our
if you have some time. I'm aware we're a little over already. There's so much to talk about, and we have questions too.
Yeah.
So it's up to you if you have time.
Yeah, I have. So it will just take like 20 seconds.
Sure.
Right. So a great example here is that if we, for example, let's take a look at the stress dispatch scenario, right? And so, for example, these requests, they are green, right? However, even though the entire request is green and it works, we can see that this get driver span here is actually recording an error. So we can just go and take a look and quickly jump to any trace, basically, right? And we can see that indeed, right? Even though that our entire trace is okay and returns correct data, some of the requests are failing, right? And we can, again, take a look and we see that there is some Redis timeout. So maybe there is some other opportunities for optimizations or improving the software in general to in turn improve reliability overall, right? And you wouldn't have been able to discover this if it wasn't for tracing and the integration between Grafana Cloud K6 and Grafana Tempo. So, yeah.
We have a question from Falcon Codes. They say, what about if I have multi-clusters and I want to show the traces in one Grafana? How can I know where traces come from?
Yeah, so if you have multiple clusters, maybe you have multiple Kubernetes clusters or whatever, if you want to have them appear in a single Grafana, you just have to send all the data from all your different clusters to your Grafana stack. So when you create a Grafana Cloud account and we provision databases for you, one of which is Grafana Tempo, you will basically get a URL to this Grafana Tempo, and you just have to configure all of your clusters to send data to this single Grafana Tempo instance. And then you will be able to see all the traces from all the different clusters in one place. One thing I would recommend doing if you have such a setup is to actually configure, for example, OpenTelemetry exporters or some other form of agent. For example, it could be Grafana agent, to add additional metadata, to add additional key value pairs to your traces. So for example, you could put a key-like environment and have their statically defined, for example, the cluster ID. So once you actually have all the traces from all the different clusters in one place, you can still differentiate, if you want, between them.
That's a good point as well. And the trace IDs are going to be unique, right? What goes into the trace ID? Like, how are they created?
Depends on the format and depends on the specification. So usually trace IDs are either UUIDs or UL IDs. So they could be lexicographically sortable. It's very hard to answer this question since there is just too many specifications for tracing. But usually a trace ID is just a long string that looks random at first. But when you actually go and take a look at its binary implementation, it usually has some sort of timestamp associated with it, maybe some sort of metadata, and then just a random part that's concatenated to the thing before, and then it's just all turned into a string.
Okay, that's good to know, because I was just going to say, well, all the trace IDs are unique, but I think your answer of like actually trying to modify it so that there is something a little bit more readable within some metadata that you can use to identify it would be a lot easier. Do you have time to answer the Tracetest question? Because I'm personally curious, because we've had them on Grafana Office Hours. I know Paul and I have met them in person. If I were at home, I would like pan the camera to show you the Tracetest and Cube Test stuff that they gave me. I have like stuffed animals and stuff from KubeCon.
Yeah,
but tell us. So what did you mean? You said that Tracetest had a different approach.
Yeah. So I tried Tracetest just a little, and I also watched your office hours with the developer advocate from Tracetest. How they approach testing in the context of distributed tracing is, I would say they think more of integration tests. So you can assert on certain spans, right? So when you make a request, you can make assertions whether spans that your system generates are what you would expect, right? Or maybe the spans where you expect to have, I don't know, a certain percentage of failures or successes, right? You can basically assert those things. And then it also doesn't offer any sort of there is also no sort of cloud solution for Tracetest, at least right now. So I would say Tracetest is not particularly well suited for load testing. Whereas we primarily tried to focus on improving the root cause analysis for load testing, because integration testing is one thing, right? But you usually can do integration testing of a real system in some sort of isolated environment, and you can always kind of try to assert it, right? But once you actually start doing load testing, this is usually when the stuff starts breaking a lot. And this is what we were aiming for, basically. And this is what my team's primary mission is to try and streamline the root cause analysis while load testing or performing some other sorts of tests. But load testing is currently at the forefront of it.
Having said that, I have another question, because I know in K6 we now also have the browser module. Is there future plans for K6 browser module support to also have tracing? Is that in the plans? Like, or can you share anything? Yeah, something around that.
Yeah, so we are exploring opportunities here. So it's possible, because I don't know how much I can talk about it, since this is the browser team's competence I'm getting into. But yes, I know that we are looking into tracing user actions in the browser, and maybe even correlating them with what's happening on the backend side of things. Yes.
Awesome.
Wow,
I
that would
can't.
be so cool.
We're so spoiled, Nicole.
I know. I just got a little shiver, a testing shiver. Holger says one last thing. To check or compare the spans or span attributes automatically is exactly where Tracetest kicks in, as it is basically observing the traces as a human would do in the front end, just FYI.
Yeah,
Yeah,
exactly.
Tracetest is really
so this
good
is
for
the
that.
feature that we don't have. We don't have
Yeah.
currently an option to assert on certain spans and the results of these. But yeah, if this is something that the community wants and customers wants, we are happy to explore this as well.
Yeah, I think the difference is that this solution, distributed tracing, at least in Grafana Cloud K6, is more about like what already happened. It's about the root cause and finding out what exactly went wrong. And Tracetest is more after that. Like it's saying, I guess that it is trying to assert on where that path was already traced, if that makes sense. It's not so much about finding the cause. It's about like the integration testing angle of like, did this go here? Did that go there? When it hit this point, did it? So it's much more of a testing approach, whereas the distributed tracing one strikes me as more of a DevOps approach to it. But there is an overlap.
Yeah, there is definitely an overlap.
Okay. Well, we are already over time. I feel like we could keep going, honestly. But if people want to know more, what's the deal? Is this thing free? Do they need Grafana Cloud K6? Can you do it with just K6?
Yeah, so this feature is currently free for all Grafana Cloud K6 and Grafana Cloud Traces customers, since you actually have to send your traces to Grafana Cloud to make it work. It's a cloud-only feature. But if you just use this, right? So we are basically a Grafana Cloud customer. It's free. There is no additional charges to do it. So just go and trace your tests. And for how to get started, we have a documentation page. Maybe Nicole can share a link. There is also a blog post regarding this feature. So feel free to go and read the blog post. And if you have any particular questions, you can reach out to us in the Grafana community forums, for example, or at support@k6.io.
Awesome. So I've put those links in the comments, and I'll make sure to put them in the description as well. So next week, we are going to talk to another engineer from Grafana. Earlier, Łukasz, you said that you know, a common engineering pattern is to have an agent that collects metrics and forwards them on. I'm actually talking to some people next week who are talking about an agentless monitoring solution for Prometheus in particular. So for some cases, you may not even need an agent anymore for Grafana Cloud. And we're going to have Matt Nolf to talk about that as well.
Yeah, you can send it just to the cloud.
All right. Thank you, Łukasz, for
so
coming
much.
to talk to us about this. This is so awesome.
It's so
I
useful.
personally loved this feature for so long, so I'm glad that it's finally out there and free for use.
Thank you so much. It was lovely talking to you.
All right. Thank you, everyone, for watching, and have a good week.